Vision-based hand gesture recognition system, which is going to be presented by Officer Cadet Santhirathne. He is also from Intake 27 from the Department of Electrical, Electronic and Telecommunication Engineering.
Thank you, sir. Good morning, ladies and gentlemen. I am most privileged to present our research on vision-based hand gesture recognition system. In this research, we wanted to develop a language interpreter with the aid of vision for the disabled people who are using sign language. The content of our presentation will be as follows: introduction, objective, methodology, experimental results, limitations, future enhancements. Today, it is in need of a new and a better way of input manner to interact human output to machine input. Human communication is mainly based on vision and sound. The best option is in use of vision and audio detection of the body language. From all the body language, hand gesture is an important aspect because the user friendliness it adds to the system. The user can communicate with a reasonable distance and doesn't need to have any kind of physical contact with the machine. This kind of human-machine interface would allow human user to control remotely through hand gestures to a wide variety of devices. Gesture recognition algorithm should be fast enough to compute any hand gesture where the user is going to show. Today, there are many applications in the fields of gaming, presentations, video conferences, media applications, and military systems. Object of our research was to design a vision-based hand gesture recognition system for differently abled people to interrupt sign language. Methodology. We used OpenCV and Visual Studio environment in order to produce the outcome. In our research project, we used a normal webcam of a laptop with Windows operation system. To implement this project, we used many predefined algorithms and methods. Methodology that we used can be presented as follows. First, we capture the video and then have to do the noise reduction, and then we subtracted it from the background. From this, we get a binary image. So from it, we do the edge detection using the canny edge detection method. From this, we get a boundary contour, and to get that to an approximate polygon, we used Douglas-Puker method. And then by making a convex hull, we get the defect points of the image, and then from it we can obtain the count of fingers which is shown on the video. For noise reduction, we have used Gaussian filter rather than the median method. We used the 5x5 Gaussian filter masked on this project. And the background removal was done by code move method. Then as a foreground, it will get any moving object in the background. Then what we get is a binary image where we need to find the area of the hand. What canny edge method does is calculate the boundary points and outer contours. After this, we find the boundary curve and with the largest area. In order to reduce the number of points in a curve with the approximate polygon, we use the Douglas-Puker method, and this is approximated by a series of lesser number of points. Convex hull is the smallest convex region enclosing all the points in the set. In this research, we have used Klansky algorithm to find the convex hull. So by defining a threshold point, we can obtain the defect points. To do that, we have to get the aid from what we have created earlier, the boundary curve, which is the approximate polygon, and the convex hull. So finding the defect points, we can get the count on how many fingers been shown. As you can see, this is the graphical user interface from our research. It displays how many number of fingers which been shown in the webcam. From this, what you can witness is, in this image, the number of fingers shown in the screen is not 5, but 4. That means the gesture of number 4 and 5 is going to be recognized by the system as two different gestures. We have faced quite a lot limitations while doing this research. One of that was we are facing with illumination variations. And shadow variations, according to it, also affected us. For example, for a demonstration, we had to use a special background where there would be sufficient illumination. Background should also be a constant background. So we used a dark linen enough to cover the area where the webcam is going to capture. Another observation was, the further the hand goes, the calculations was going wrongly. So we had to go for a constraint that the hand should be placed within 20 centimeters from the camera. And still, this algorithm doesn't work for certain angles when we are placing the hand. So we had to go for another constraint that the hand should be pretty much perpendicular to the webcam so that the camera could get a good capture of it. Future enhancements. As seen by many angles, this project mainly focuses on developing a device to defected people who can't communicate with speech. Making a usable output such as voice per gesture being detected with the system undoubtedly enhance the quantity and quality of the richness of the project. With the use of sign language interacted with this device, this technology would be much benefited to those people. Most interesting thing would be developing this as a mobile device. To change the way the users interact with computers by eliminating input devices such as joysticks, mouse, and keyboards would be another application of this. Converting this project to an Android application would be the most appropriate way to develop this. As a mobile application, this can always access the camera and a sufficient operating environment which it needs. This is a continuous project, and we hope that other badgers who would be keen enough to follow this research would add sufficient enhancements and put up a very good outcome more than this. Thank you.